For the last 2 decades, the mission was crystal clear: Mars. That was the whole point of SpaceX, right? It was the gospel according to Elon Musk. Every dollar, every engineer, every waking moment was supposedly aimed at one thing: building a self-sustaining city on the red planet. Everything else? Just a distraction. Or so we were told.
And then, bam, out of nowhere on a random Sunday in February 2026, the entire script flipped. In a single, almost casual post, the Mars dream was shelved. The moon, the distraction, was suddenly front and center. Priority number 1. You could literally feel the whiplash across the entire aerospace world. So, what gives? This wasn't some random whim. This was a calculated, strategic pivot. It was driven by brutal physics, cold, hard cash, and a new space race that's heating up faster than a re-entry vehicle. We've compiled the intelligence dossier, so let's break down the 5 key files that explain this massive, sudden shift to the moon. Okay, let's open file 01. This is all about speed. See, SpaceX's entire DNA is fail fast, learn fast. But here's the thing about space. You don't own the clock. You're on a cosmic schedule, and it's dictated by the unforgiving laws of physics and orbital mechanics. And this slide right here, this nails the core of the problem. Trying to get to Mars is like waiting for a bus that only shows up once every 2 years. If you miss that window, that's it, you're stuck. The moon, though, that's like calling an Uber that can be there anytime you want. That's not just a small difference. It fundamentally changes how you can develop and test anything.
And this is every space engineer's absolute worst nightmare laid out in 5 excruciating steps. Imagine this. You spend up to 2 years just waiting for the right moment to launch your new widget to Mars. It takes 9 months to get there, and when it finally lands and you find out, the space toilet is broken, you can't just send a plumber. You have to wait for the planets to line up all over again. The bottom line is, your turnaround time to fix one single problem on Mars is around 3 years. 3! For a company like SpaceX that's used to building, testing, blowing up, and then rebuilding rockets in a matter of weeks, that's an operational eternity. Their fail-fast model completely falls apart at that kind of timescale. Now, let's flip the script and look at the moon. If that same toilet breaks on the lunar surface, you could have a totally redesigned, better version delivered and installed in less than a week. You can test things, break things, and improve things 100 times faster. The moon isn't just a stepping stone anymore. It's the ultimate high-speed proving ground for all the tech you'll eventually need to get to Mars. But this pivot isn't just about making life easier for the engineers. Let's open file number 2. This one gets a lot more serious. This is about survival. This is the scenario that keeps mission planners up at night. For the first few decades, a colony on Mars would be completely, utterly dependent on Earth for, everything. Food, spare parts, medicine. If something catastrophic happens back here, a massive war, a global pandemic, anything that stops those resupply ships from coming, that colony is toast. It's a slow, cold death sentence 9 months away from any possible help. This slide really brings the point home. A Mars colony, it's a tiny, fragile lifeboat floating in the middle of a cosmic ocean, a 9-month journey from shore. A moon colony, just 3 days away, is a lifeboat that's still securely tied to the dock. From a risk management standpoint, it's just an infinitely safer, more logical first step to becoming a multi-planetary species. Okay, so the moon is faster and it's safer. That's pretty compelling. But file number 3. This one reveals the real driver, the one that reroutes everything: the money. This pivot isn't just about exploration, it's about building a business, a very, very big one. This number really says it all. In early 2026, SpaceX merged with Musk's other big venture, the AI company xAI. The new company was valued at over $1 trillion. We're not talking about planting flags anymore. This is about building an industrial empire in space. And it all starts by solving a huge problem we're facing right here on Earth. See, the AI models running our world are getting incredibly powerful, and they're hitting a physical wall. On Earth, data centers are sucking up the energy of entire cities and need massive amounts of water just to keep them cool. But on the moon's poles, you get near-constant, unfiltered solar power. And even better, you have the single most effective cooling system you could ever imagine, the hard vacuum of space. It's a perfect, infinite heat sink, and it's totally free. The new plan is to turn the moon into a giant off-world server farm for the next generation of AI.
So, how do you build all this stuff? You use the moon's natural advantages. With only 1/6 of Earth's gravity and no atmosphere, you don't actually need rockets for everything. You build a mass driver. Think of it like a giant electromagnetic cannon, basically a railgun, stretching for miles across the lunar surface. Using solar power, it can just fling things, satellites, refined materials, whatever, directly into space. No rocket fuel needed. The moon stops being an expensive destination and starts being a factory that makes money. But this whole industrial vision isn't happening in a vacuum. Let's open up file number 4. This one's about the new space race, and trust me, it is on, and it's forcing everyone's hand. The US is not the only player with its eyes on the moon. China is moving with incredible speed and a very clear state-driven strategic goal. While NASA's Artemis program is a mix of science and commerce, China's program is all about industrial development and strategic control. And this isn't some far-off plan. After hitting over 60 successful launches in 2023, China is on pace for nearly 100 in 2025 alone. The pressure is on, and they're both aiming for the exact same patch of lunar dirt. So why the South Pole? It all comes down to water. The craters at the poles that are always in shadow, they're filled with ancient deposits of water ice. And in space, water is basically gold. You can drink it, you can breathe the oxygen from it, and you can crack it into hydrogen and oxygen, the main ingredients for high-powered rocket fuel. Whoever controls the water basically controls the gas station for the entire Earth moon economy. It's the most valuable real estate off-world, and the land grab has already started. And that brings us to the most practical, down-to-earth reason of them all. Look, Musk can talk about Mars all day long, but his landlord, NASA, is paying him almost $4 billion to build a lunar lander for the Artemis program. He has a contractual obligation to go to the moon. Ignoring that would just be bad business. This pivot brilliantly lines up his company's long-term industrial dreams with its immediate financial and national security needs. But let's be very clear. This grand vision is nowhere near a done deal. Our final file covers the critical risks, the things that could totally derail this entire multi-trillion-dollar plan. First off, the logistics are a complete nightmare. To get a single Starship to the moon, it might need to be refueled in Earth orbit by a chain of 10 to 12 separate tanker flights. That is an insanely complex orbital ballet where one tiny mistake could be catastrophic. Meanwhile, Jeff Bezos' Blue Origin is developing its own lander that they claim won't need orbital refueling at all, which could give them a massive advantage. And then, there's the moon itself. That is how the lunar dust, the regolith, was described by the Apollo astronauts. It's not like sand. It's microscopic, jagged shards of glass and rock. It's electrostatically charged, and it gets into absolutely everything. It shredded spacesuits, it clogged up machines, it destroyed seals. Now just imagine what that sharp, invasive dust could do to the sensitive robotics of a factory running 24/7. So that's the big shift. The romantic, exploratory dream of a new frontier on Mars is being replaced, at least for now, by the tough industrial reality of building a factory on the moon. One was a vision, the other is a job.
And that's really the key takeaway from this whole thing. SpaceX hasn't given up on Mars. They've just realized that the moon is a necessary and profitable first step. It's where you test the tech, prove the economics, and build up the industrial muscle to finally make that Mars colony a reality. The moon is the hard, gritty job you have to do to finally afford the dream.
Which leaves us with the final assessment. Musk is betting his whole empire on this lunar factory. But what happens if the reality on the ground is just too harsh? What if that glitter made of knives literally grinds all the machinery to a halt? Is this a pivot of strategic genius? Or is the entire plan about to get chewed up and destroyed by the very environment they're trying to conquer? That, right there, remains the trillion-dollar question.